All right. This is problem number 17. I'll do 4 of these problems for you, and then I think we'll be done. Because once I kind of explain to you what I'm getting at here, I want you to be able to, I think that the rest of it is pretty straightforward. I think the first question that I ask is, what is the degree? What I want you to be able to do is I want you to take a look at these formulas, these polynomial formulas, and from that, tell me as much information as you can about this graph. All right, let's take a look at this thing. My polynomial for this thing is to the 4th power. It's to the degree 4. So if you're asking me what is the degree, my answer is 4. The reason being is because the exponent that I see on here, the highest one is the number 4. All right, what is the leading coefficient? Well, the leading coefficient is the number in front of the highest power variable. So this thing's x to the 4th power. The number is -2. That's all I want. Because from that pieces of information, you can get what the degree is and the leading coefficient is. From those two things, you can get what the graph looks like. I know that this graph is going to start and end in the same direction. I know that this graph is also going to start down and end down because of that negative. I don't really care about that too. I really care about whether or not the leading coefficient is positive or negative. That's all I'm really looking for. So since it's -2, I know that it's probably going to start down. It's probably going to do something funky in the middle, and it's going to end down. And I can actually tell you exactly, well, not exactly, but I imagine it would probably look something like this. Don't get me wrong, I don't really know by looking at this what the shape of this middle stuff will look like. I'm just guessing. I know that it's going to have, it could have up to 1, 2, 3 bumps. But beyond that, I don't really know where this thing crosses the x-axis is and all of that kind of stuff. I'm just guessing what that might look like. Really, the most important pieces of information that I can guarantee you is that it's going to start down and it's going to end down. There's one more piece of information that I can get just by looking at this, and that's the y-intercept. To get the y-intercept, if you want to find the y-intercept, you always set x equal to 0. Because if you want to find the y-intercept, you want to find it along this vertical line right here. If you're anywhere on this vertical line right here, x is equal to 0. Now, one of the things you should notice is that if x equals 0, it's kind of nice because you multiply, like 0 to the 4th power is still 0. Multiply that by -2, you get 0. So if plugging in x equals 0 kind of kills everything that doesn't have an x in it, or that has an x in it. If it has an x in it, even if it's to the 4th power, if it's cubed, if it's squared, all of that kind of stuff, if you're taking 0 to the whatever power, then it's equal to 0, and you multiply that by anything, it kills it. So really, my y-intercept is every number in here that doesn't have an x next to it. The only number that is 7, -7. So I messed up my graph a little bit. Maybe the graph looks something like this. I don't exactly know, but one thing I do know is where it crosses the y-axis is -7. And I can tell you that just by looking at this polynomial. I look at that polynomial, tell you it's the 4th degree. Boom, I know that it's going to start and end in the same direction. I'm looking at that coefficient in front, that's a negative number. Boom, I know that it's going to start down and end down. If it were a positive number, it would start up and end up. I know that the only number in here that doesn't have an x next to it is -7. That means if I plugged in x equals 0, this would be 0, this would be 0, and this would be 0. The -7 would still survive, so my y-intercept is -7. I think that's all the information you really need from this thing just by looking at it. That's what I want you to be able to do. I want you to look at something and just, boom, think about what the graph might look like in your head. Yes, of course, you can use a graphing calculator to graph it. Eventually, I will give you the ability to use a graphing calculator, or even better yet, graph it using math and algebra and all of that kind of stuff. But for now, what I want you to be able to do is to take a look at an equation and just kind of, that should be what it looks like. Because here's the key, is when you use a graphing calculator or when you graph it by hand, you want to be able to step back and say, well, did the graph I get line up with what I thought it might have looked like? Because I guarantee you that there will be a time when you graph something on the graphing calculator and it looks totally nothing like what you thought it might look like. And here's the problem, is usually what you think it might look like, usually by doing these kinds of techniques, you'll be able to guess what it looks like, or you'll be able to see immediately, this is what I should get. And usually that one's the one that's right. Then you go back and you find out, oops, I forgot to carry this negative. Oops, I plugged it into the calculator wrong. You don't normally plug it into your brain wrong. I want you to be able to do these kinds of things.